Hey guys, this is Philip Morrow in the Austin, Texas office, and I'd like to look at simulation in SOLIDWORKS 2017 by taking a look at this battery pack, this battery covered door. This is a door that's going to have to be opened and released several times, so I've set up a simulation just over in the part window where I made use of some symmetry. This part has a bit of a living hinge, so I've used a prescribed displacement to push this face in about 2.3 millimeters where it would need to snap into place. Now I'm going to run this, and I might walk away from my desk while it's running, but what happens when a dialog message pops up that you may have missed? Well, in SOLIDWORKS 2017, you don't have to wait on those. They can automatically be dismissed and answer ahead of time. In this case, a large displacement analysis needed to be run, and even though I walked away from my desk, that would happen. And when I got back, I would see a report showing me every dialog message that came up, along with the answer that was chosen, so I know I didn't waste any time. The solve kept moving forward, and I can see exactly what decisions were made along the way, even though I was away from my desk. Now this looks like a pretty high amount of stress. I can interact directly with the color chart to try and get an understanding of what's going on here, but what I'm going to do is ask SOLIDWORKS 2017 to run a stress hotspot diagnostic. Now this allows SOLIDWORKS to look over my simulation setup and tell me if there could be any artificial stresses or hotspots set up by maybe the simplification of the model or my setup specifically. I can even visualize these to see exactly where these errors might be taking place. And in my case, it's actually true. What I've done is omitted a very small fillet that would have existed in the injection molded part, but is not here in my model. Now it would be nice to run this maybe as a nonlinear study since I saw that large displacement analysis, and as I duplicate the study, notice I have the ability to change study type on the fly so that I don't have to duplicate any of this setup work. I immediately get a nonlinear study. In fact, I don't have to know any more than that. If you go into the properties of a nonlinear study, all of this is set up automatically, including the decision of which solver to use, so I know I get the fastest solve time based on my specific setup. Now, I've run this ahead of time, so let's go ahead and view the results, and you can see that they're drastically different. I'd like to compare these side by side, and SOLIDWORKS has always given us the ability to do this. But in this case, I'm going to compare the two stress results, this one I've run ahead of time and the one that we just ran together. And what I'd like to do is use the color chart from one of these, so I'm comparing the exact same values for red on each one of those plots. Once I do this, I can see it was actually pretty necessary for me to run a nonlinear analysis and get a better idea of what the stresses are going to be and what their distributions are. In fact, we could take this further. When I'm explaining to someone what design changes we need to make based on the simulation, instead of just staying in the simulation tab, I might want to move back over to the model tab, but I lose all of those plot colors. In 2017, we can make use of the simulation display and use the real view power of our graphics card to show one stress plot or another, even in the deformed results. Here, let's take a look at the nonlinear stresses, and these stay in my regular model environment, so I could go ahead and photo render them with PhotoView 360 or even 3D print these out in a color supporting printer. As you can see, 2017 makes simulation not only easier, faster, but easier to post-process these results and share them and explain them to your coworkers. I hope you get your hands on 2017 today. Thanks for watching.